Um,
Hey everybody, just getting set up here and ready.
Good morning, good evening, whatever it is. I think I have to turn off the sound from the YouTube stream because otherwise I get the echo. I hear myself 30 seconds later.
Yeah. Okay. So then I would say let's get started.
Yes.
So this week we have a new chapter about the environment, and as with most of the other things in the book as well, we had an environment chapter in the previous edition of the book, and we have one in this edition of the book, which is completely rewritten. Like we didn't even look at the old chapter, write the new one. So let me see if I can share my screen quickly and go over that, what we have in there. So where's the book? Here's the book. Okay, so this is chapter 5 in the book, and as always, we have annotated a lot of the sample code with the view trees that are really important for understanding the environment. And yeah, so we have much more illustrations like that. And then we go in this chapter, there are a few parts to it, right? The first, we go over how SwiftUI uses the environment, how you read from the environment, how you write into the environment with custom environment keys. So how you can use it for your own things. And then we also go over how you can write, how you can use the environment for example, creating custom component styles like SwiftUI does. So SwiftUI, for example, has button style, where you can apply a common style to all buttons in the subtree, or where you apply the button style modifier. And we go over this to a certain extent, at least, that is feasible for this book, how you would make something like this work. And yeah, then there's a little bit about environment objects, which of course has some changes now with iOS 17, because we can just say we don't need add environment object anymore, we just use add environment. And yeah, so that's pretty much the environment chapter, which in the end, the environment is always kind of a concise topic, right? There's not that much to it, but it's super important for SwiftUI.
Yeah, it's very simple in a way. Once you get it, it takes maybe a little while if you've never seen this before. It's just values that go down the tree, but it makes everything possible in SwiftUI. So this is why we can just have, buttons, and then somewhere outside we set the button style, or we have a text and the environment allows us to pass the font on to the text, and the text picks it up. And likewise, the whole pattern where for the people coming from UIKit, if you remember, like the locale, the auto updating current locale, where you need to observe things, like all of that now happens in the environment, and anything you get from the environment will be updated automatically, and like you don't have to worry about all of these dependencies anymore. And I think there's a couple of ways of looking at it. So sometimes we see in SwiftUI that the environment gets sort of used to replace singletons, and other times it's used to really, like with the button styles, for example, you often would use this where you have like maybe a global button style and then local ones specific to your view. And the same with the font or with the foreground color or tint or something like that. Like these are often used both, not so much like as a replacement for singletons, but really to control local view trees and change things there without having to pass all these values around manually. And yeah, in our experience, it's also one of the most robust parts of SwiftUI. Like just works typically. I don't remember the last time we had a bug with anything there. Maybe, do you remember anything, Florian?
No, I don't really recall. I mean, there was things about sheets and stuff like that, right? Everything in a hosting controller, basically these kind of issues. But like in terms of just SwiftUI, like pure SwiftUI, basically, this has been super stable since the beginning. And yeah, so and perhaps we can loop in one part of a question at least that we have on GitHub, because it's related to that. And because let me see, do I have a name here? Dimitro. Yeah, Dimitro asked a question about exactly that, the environment and state objects. And he said, well, he's wondering how we can inject things into like not just views, but perhaps something like state objects or something like that, right? And he said, well, if you look at, for example, the fetch request property wrapper, that also somehow can do it, because it implicitly will use the managed object context from the environment. And so maybe we can use the environment in our model objects as well, or something like that. And so by default, there are just a few places where you can read from the environment, right? That's views, that's view modifiers, and these dynamic properties can also read from the environment. That's why this add fetch request property wrapper, for example, can do it. And so just if we have some sort of a model object that uses a state object or observed object or observable object in iOS 17, there we cannot just read from the environment. By default, there is no mechanism here really to inject anything into anything else but views, view modifiers, and dynamic properties. I don't know if you have any more ideas about that.
Yeah, I think the big thing with environment is that it's really a way to pass values down the view tree, and so for the environment to work, it needs to be like the environment property needs to be part of the view tree, and objects like model objects are not typically, and so this is, I think, why it's like this, and there are things inside the view tree that don't get an environment, which also, I don't know, makes sense a little bit. Like, for example, a shape, you cannot have environment properties in there. Like, you can have them, but they don't work. And that's probably because shape, it's never used directly as a view. It's always inside a shape view, and that internally could probably access the environment, but shapes cannot. And I think so that's the key. Like the environment might differ from view to view, and your model object might be used across multiple different views, and like which one should it pick? And this is also what's also very interesting is you can create in your body, you can create a view, and just in your view body, you can say something like let x equals my view. And then my view can have environment properties, but you can only read them inside the body of my view. If you read them before, the view is not part of the view tree yet. And so the environment properties don't make sense. And you get warnings for this as well. But this is because the view really needs to be inside, like it needs to have an identity inside the view tree or the render tree, actually.
Yeah, and it kind of makes sense that since SwiftUI is a pure view layer, it's purely a view layer for your app, it doesn't really have any mechanisms to do dependency injection into your model objects or something like that. That's really a totally different domain.
Yeah, I mean, you can do stuff if you really want to. You can build stuff there, right? Like that. Where your model objects, where you always pass on some environment values. The other thing is that the environment in SwiftUI there's a few different parts to it. So the actual values is part of a type called environment values, and the add environment property wrapper or the environment type, that's only used to read values, and it also causes the view to redraw if any of those values that you just read change. And this is also what would you do in your model object. And like, how do you subscribe to environment changes in your model object? What would happen there? Like, it cannot redraw the model object. And this is, I mean, it's a really good question, because I think we tried this a bunch of different times in different places, right? Like, this is a very normal thing to expect. But the moment you start to really understand, for me, the key insight was when we tried to re-implement this, and then you're like, yeah, it makes total sense. I cannot implement this correctly. And then it sort of clicked for me that this is why the limitation is there.
Yeah. Okay, so that's the environment chapter. Basically, that's what we have for this week in the book as new content. Shall we just jump over to some more things we have on GitHub?
Yes. Before you do that, so you talked a little bit about styling components, and there's also a really nice blog post. I think we refer to this in the book as well, but I'll try to share part of my screen. Here we go. So this is a really nice blog post by Moving Parts, where they also show how to do this in a much or I think we have like 2 pages, and this is like a whole bunch more. So anybody who's interested in building like their own components that you can style through the environment, similar how you could, for example, style a button through the environment, this is the post to read. And there we also have Swift Talk episodes about that as well. Yeah, I can maybe start with the first question also.
Go for it.
So this is, we briefly talked about this last week. So the question is view tagging necessary? And we show that on page 37. I don't have the PDF handy here, but what we did is we created a picker and then for each, and then we gave every item in the picker a tag to make sure that it matches up with the picker. And it's actually in the documentation. I'll pull this up as well. So here we go. Here we see an example with a picker for each in the text, and there's no tag. And it actually says this explicitly, that for each automatically assigns a tag to the selection view. So this is part of for each. I think here it's not in the documentation of the for each. So you have to sort of know where to find this, but it is in the documentation of the picker. We go back one step. So I think it wants to go back. Well, it is in the picker documentation, and so when the type of your binding matches the identifier or the ID property in the collection you're iterating over, then you can leave up a tag. The thing where you have to use it, I don't know if they have this in the documentation as well. Sometimes you have a mismatch in the type. For example, if this would be an optional type, then you need to provide an explicit tag with an optional flavor.chocolate, an optional flavor.vanilla. That's something to be aware of. But you'll notice quickly, this is one of those things, the compiler won't cache it for you, but you will notice quickly that your picker doesn't work. So that's something to be aware of.
Okay, so maybe let's jump to the chat in between. So Franklin asks, where do you draw the line when deciding to pass an object using add_observed object versus add_environment object down the view tree? And yeah, it's a good question. I would say, well, you can use both to actually pass something down the view tree. The difference is really that with observed object, you have to pass it every step of the way. And with the environment object, you can kind of skip many levels in the view tree and kind of magically read it somewhere down your view tree again. And I don't know, I think it's hard to tell exactly where to draw the line. I think it's a judgment call, basically. If it's just something, well, maybe you could say an environment object is really more something that potentially, like, at least a large part of your app is kind of interested in, you know, or you might be interested in various parts of your apps that are kind of very far apart. And if you just need something locally, like you instantiate a model object with a state object property wrapper, for example, and you just need to pass it down to 2 subviews or skip 1 level and pass it down 2 levels, then it's maybe a little bit overkill or maybe too magical to put this in the environment. But in the end, there are no rules for that. I would say it's kind of, you have to try it and see what works for you.
I think you can even ask the same question about configuring a view with a property or a value and configuring a view to the environment. And often you will have both. So if you think of a button, the action and the title of the button are typically unique to that button. So those you need to pass in directly, whereas the button style is often a little bit more global or very global. And sometimes those are like 3 examples: the title, the action, and the button style, where to me it's very clear, like the first 2 should be part of the button itself in the normal property, and then the last one should be in the environment. But and I think for most cases it is often pretty clear, but yeah, it's not always so clear cut. And one challenge, I think, like, I love passing things down the environment. It's my favorite hobby. No, but I like the environment and I like working with it. But one challenge, of course, is that it's a lot harder to discover. So these APIs where you can say that button style, you have to sort of know it exists. And for me, like, we've done so much SwiftUI and always look into this that we sort of know, I would say, like 90% of the APIs, and it's all fine and we can use all of it and we have no problems discovering things. But I noticed last week when we used the Swift charts framework, you can also style a lot of the things through the environment, like in a very similar way. And there I found it much harder to discover what APIs I could use where. And I imagine it's the same when you don't know the SwiftUI APIs that well. So the environment, it enables the very concise syntax, but it's also causing, I think, or harming the discoverability of APIs.
Yeah. Okay, let's move on to another question we have on GitHub, and there's one about bindings. So let me see if I can get this on screen here. I think it's this one. Yes. So here we have a question about why is the setter of the wrap value property of the binding property wrapper marked as non-mutating, right? So we, in the book, in the state chapter, state and binding, we also go over bindings step by step, like build them up basically from how, so to understand how you can think about them, how you would write something like that. And there we also use this technique to have this wrap value property. So this would be inside of the binding property wrapper. You have this wrap value property with a getter and a non-mutating setter. And we can take a look at that in XCode as well. So let me pull up my XCode window here. Where is my XCode beta? Let me see this one. Yes. So this is the property wrapper binding, right? When you look this up. And here, when you scroll down a little bit, you can see the public var wrap value with a getter and a non-mutating setter. So that's what he's referring to. And the reason is basically that if you, so this is a struct, right? The property wrapper is a struct. And if the setter of this wrap value, which is what you change, for example, in a button closure or something like that, if this would be mutating, so if it would be just set without this non-mutating keyword, then the compiler wouldn't let you change it, because to be able to access the setter of a property on a struct, you need to be in a mutating method or a mutating property. And by marking this as non-mutating, and this behind the scenes, of course, this is kind of using some reference-based storage for the value. And so it's actually non-mutating. So they can safely mark it as non-mutating. And this allows us to actually change the value of a binding property at all in our, let's say, button closure or whatever it is. Otherwise, the compiler would just complain. This wouldn't work. Right? And so that is basically, that's the reason this annotation is there. Yeah, Chris,
it's a little bit of a lie, right? That it's a little bit of a lie that the binding is like, and the same with the state property and all these properties. Like you can just mutate them without being in a mutating method, and I get it. Like structs look nicer somehow, but this doesn't have any value semantics as you would expect from structs. So
yeah. Good point.
Yeah, it's just, I think it's sometimes like I like it and I don't mind the way they did it, but it also feels like it's sort of optimized for nice code and not necessarily the easiest to understand like how it actually works below the hood. Because it's like bindings and specifically I think state and all of these things, they're somewhere like in between structs and classes. Like they have identity and they're part of a view, and only then they have the identity, but it's also not really a class, and like it's a weird mix in between.
Yeah, but you see that a lot, right? We had this the other day when so just today we released the first Swift Talk episode, which is public, by the way. Everybody can watch it, where we try to re-implement the observable mechanism in Swift that we got now and that SwiftUI now uses. And we encountered something similar there, right? You have this registrar type or something like that each object uses. And basically this is also a struct. And but then it just internally has some kind of a reference-based storage, but to the outside it's a struct. It's a very similar thing. And you see that in many places, I think. Yeah. And so that's basically the first part of the question. Let me get to the second part of the question, because that is also interesting. So let's come back to the question here. So the second part of the question is here. This also got me thinking that I don't really know how SwiftUI handles properties that are not annotated with property wrappers, because for everything else, there's got to be some reference-based storage going on. And yes, that's exactly right. So if you have state properties, if you have bindings, which are basically just setters, getters and setters on for example, state properties or other things like state objects or whatever it is, there's always some sort of reference-based storage going on. But what's happening with normal properties in SwiftUI? So if you just have a view and a struct my view, and then you define normal properties on there, what's happening with them? Is there anything special going on?
I think not. So I think what's happening there's a few things. So I think SwiftUI will try to see like it. Well, there is some kind of reference going on, and that's SwiftUI I think captures the latest value of your view. So this doesn't include the body property, but this includes like all the properties you have in your view, and then when the parent view re-renders and it creates a new value of your view, and it will look in the render tree and it will see, like, did anything change? And SwiftUI has a number of different strategies for this. I think they use or used to use something mirror-based, or maybe something more low level that works similar. They will even go as far as doing a mem compare and see if the memory changed. And if the memory actually didn't change, or if you use, I think it's called equatable view, something like that. If you use, like, if SwiftUI figures out nothing changed, then it will not re-render the body of the view. Even if maybe something did change, but as long as SwiftUI is convinced nothing changed, it will not re-render. And you will have to work to, like, if you want to sort of get around that and make sure that SwiftUI doesn't re-render, but you did change things, like, you will have to actively find a way to hide your changes from SwiftUI. And you can do this, maybe you could do this with like objects that don't conform to observable object or the new observation stuff. But yeah, SwiftUI detects, like, it just knows, like, okay, something changed, I need to re-render the body of the view.
Yeah, so I would also say, like, just normal properties on view structs, they are just normal properties on structs. There's nothing special about them, and you should use them always if you don't need anything else. That's basically your first tool. It's just a normal struct. If you just want to pass a value into a view or something like that, just use a normal property. And if you also need to change this property, then things change, right? Then you might use a binding, for example, if this view only needs to change the value, but it's not interested in owning this value, or like if it's not interested in where the source of truth of this value actually resides. And then there are different things, right? If you need local private view state for a simple value, then you use @state and stuff like that. But if you don't need this functionality, you just want to pass values to a view, just use a normal property, and they will just behave like a normal property. And there's no reason for SwiftUI doesn't have to do any kind of magic to observe if a normal property changes or something like that, because the only way how this can change is that the body of the parent view basically got re-executed and passed in a different parameter to the view. And then SwiftUI already knows, okay, this view got recreated. I need to check if something changed from before. And so it doesn't need to hook into normal properties in some special way or something like that.
Yeah.
Okay.
There's another question a follow-up question from Franklin about if there's a penalty to overusing environment objects. I would say we don't know, because we hardly ever use it. We almost always, in the small apps that we write, we use normal values in the environment and not objects. I think so. Specifically environment objects, so that's basically the old way or the current way of doing things. Every view that observes and with an environment object will always get redrawn anytime anything changes in that environment object. So let's say you have a user in your environment object, or that you read through the environment object, and the user object changes a lot, then any view that depends on it will get redrawn. This will get a lot better, I think, with the new observation APIs, because there it's property based and not object based. And so then it will only observe individual properties. So that will be hopefully much better. But yeah, I think what is the overusing, right? Like if your views depend on those values, then you want to pass them around. And the question is sometimes, like, if you have performance problems with specific views, and you can think about, do I actually need to pass around the entire object, or can I maybe get by with just passing one or two values? And then SwiftUI can figure out that those values, for example, never change. And so it doesn't need to re-render the bodies of those views. It's very hard to tell, like generally, whether or not you're overusing it. I think this is something like, as long as you don't have any performance problems, like why not?
Yeah, but so I would say the potential problem doesn't really lie in putting too many environment objects into the environment. It's more like having your views depend on too many environment objects. That's probably the greater hazard. It's not like that it's super costly to pass them down the view tree. It's like if your view depends on many objects, that's talking like pre-iOS 17, let's say, this could get out of hand quickly, because it's just, if anything changes, as Chris said, in one of these objects, the view will be redrawn. And yeah, I think this situation will change with adoption of the observable stuff. But yeah, I think that's a greater hazard than passing things down the view tree itself.
Yes.
Yeah. Let me take an easy question. Have you tried Swift Data yet? No, we haven't. So we cannot really say anything about it. Still busy getting the next chapters ready here and figuring out the changes to what we already have in the book. So we haven't taken a look at Swift Data yet.
Yeah, there's another question by David about, it's in on GitHub. Let me see if I can share my screen again. Go and share the question. So how do you combine environment object, bindable and observable? So we haven't had the time to figure this out. So let's try to do it live. So oh, I think I have the old Xcode, so I need to fire up the beta. I'll close up this one. Let's see if my Xcode beta launches. Yeah, so I think I don't think this can work directly, but I imagine you could do it in 2 steps. So the first thing is like we need like a final class counter, which is our model object. So value would be 0, and this will be observable. We need to import observation and probably change the target of our app as well. Make sure that this is 17. And
you need to change your, yeah, exactly.
Simulator. So now we should be able to have like a nested view, and we can have nested here, and we can do something like over here in the environment. We should be now be able to say something like, or maybe that's created over here. I call it model counter. Okay, yeah. So my model, and what this will do is it'll take the type, use that as the key, and now over here we can, in the body, so the compiler is happy. Now we can say add environment, and here we can say the object, the type. So this would be counter itself, and say model is of type model. And there's, I think,
counter.
2 variants of this. Yes. So you can define it like this, and this will crash if you forget to set it. And then there's the variant where you say it's an optional. So there's 2 initializers and environment for this. So okay, so we can actually we can create a button and use model with value. And inside the button we can say model with value plus equals 1. I think this should work. Let's hope it does. Here we go, the simulator. We had some simulator problems before, but I think it just takes a while the first time.
Yeah.
Okay, so what should happen is we change the model. Yeah, so this works. Okay. Now the question is, can we create a binding out of this? So could we create something like a stepper and say value, and here we cannot, I think, say model.value, or we can see, and then we can say 0 to 100. I don't think we need those values. Yeah, and the reason is because the environment doesn't work like this. So it's a get environment, I think, is get only. And we cannot just, create a binding out of that because it's get only. So I think the only way to make this work is with a helper class. So you could do something like with bindable content view, and then maybe also have that's an observable. And then you could do something like, well, this thing needs to be a view. And you can say, so body will be some view. And then the content will be something like to content. And then here we need a bindable var. And I was thinking like this maybe. And then here you do content value, something like that. Okay. So it's not quite happy yet. This is initializer. I think I'll try it for a little bit, and then if it doesn't work, must be an object. What does it say? Confirms observable. Oh,
You just drag something down.
yeah. Yeah, I think it will be something like this, like
yeah, the error message is weird, right? Because O is observable, so I'm not sure.
Yeah. Maybe, yeah.
I think the issue is something else, but I'm not sure what it is.
Probably, yeah.
But so what you're trying to do is like you're trying to read the object from the environment and nest it, let's say, and then use this view where you pass in the object, and then you can write add bindable in front of it. That would be the idea.
Something like this.
Yeah.
And I'm pretty sure you can make this work. So yeah. I think something like that. Yeah. I'll see if I can figure it out. Probably like once the live stream is offline, I can write it in half a minute. It's yeah, I will. Yeah.
Nice. Okay. So there's perhaps one more thing we can talk about in this question about Combine and the observable framework and this whole story. And so basically the question is like, or like the sentiment of the question perhaps is, Combine seems to be on the way out somehow, or like SwiftUI dropped the dependency, and now we have Swift observation. And so Combine, of course, could do many more things. And can we just use observation for other things than just use it in SwiftUI? And I would say, well, let's see what happens with observation over time, right? They might expand that and add features. For now, it's just super specific for what SwiftUI needs. And if you can live with that, if that works for you, you can use it for anything, right? But you have to be aware that it's super limited in what it does. So basically, I would say there are three important things to remember here. First is that you only get events for will set. You only will get will set events, basically. Then you don't know what changed.
Maybe to add to that, like you get events for will set, and what that means is at the time you get the event, you cannot read out the value yet because it's not there yet.
Yes, and you don't get the new value either with the event or something like that.
You know that the object will change at some point.
Yes. And then the other thing is that if you use this with observation tracking API to track your changes, actually, if you access, let's say, multiple properties or even multiple objects in there, you will only get notified once if any of the things you accessed in this apply function of the observation tracking changes. So it's basically like maybe you've accessed 6 properties of 2 objects in there. If any of these changes, you will get this callback once, and that's it. And then you have to, again, use with observation tracking, execute this code to re-establish the observation tracking, basically. And so you don't know which one of the things you access changed. You would have to wrap your accesses individually in with observation tracking to actually know which value not even did change, but will change. So yeah, I think it's obvious that this is was created very specifically to what SwiftUI needs, and perhaps it will morph into more over time. But for now, it's really super specific.
Yeah, and maybe also again to add to that. So if we think about how SwiftUI uses it, it's perfect for that. So SwiftUI, like let's say the body of a view executes, and SwiftUI wraps that inside the with observation tracking. So only the properties that you access in the body or inside like helpers, stuff like that, only those properties, but all of those, they get tracked. And then when any of those property changes, SwiftUI will invalidate that view. And then in the next render loop, it will re-execute. So it will automatically sort of subscribe again. So it doesn't need to know more than one, or it doesn't need to get more than one callback. It doesn't need to know which properties changed because it will re-execute the entire body. And this is why it's perfect for SwiftUI. But like, if you can live with it, and if that's fine for your use case, then by all means, like it works really well. I think from our very limited testing, it seems super solid, but it's also extremely limited. But if you can make it work for you, then by all means, I'd say.
Okay, then I think the last thing that's open from GitHub is the famous architecture question.
Yes.
So, which is just connected to what we covered before already with the environment and state objects, and can we use the environment somehow in our model objects? This kind of question, and then it goes into the more general idea. What's our idea with regard to architecture and stuff like that? And well, I don't know. There are multiple answers to that, right? So one answer could be we are sort of the wrong people to ask about that in many regards, because we don't build large-scale, complicated apps with, I don't know, dozens of developers in many teams. So we don't have experience with that, really, especially with regard to SwiftUI, and so. Yeah, so that's the first disclaimer. And other than that, I don't know. Yeah, I think it's the SwiftUI really leaves this question wide open, right? I would say even more so than UIKit, because UIKit was this kind of was always integrated in this MVC kind of model, although it didn't really say much about the M part. But SwiftUI is even less involved basically in any of that. It's just a view layer with a very simple model interface, which is basically object will change from observable object or the Swift observation stuff. And so the question really is wide open what you do there. And yeah, I don't know. I personally, I would try to stay away from kind of large scale, this will fit all my needs into the future indefinitely architecture ideas somehow. I think I would just try to grow it organically more because yeah, I don't know. I'm always a bit wary about adopting something very complicated to start with. But yeah, on the other hand, I think that comes back to the initial point. You definitely need to do something, right? You need to lay down some sort of rules or norms if you work with many people on a large project.
Yeah, and I think this is also for me the key point. Like a lot of these architectures that exist, I feel are a bit too complicated. But the big advantage they bring is that they give you if possible, they give you one way to do things. And this is especially true for, I think, TCA, where it's very clear, at least from my understanding of it, that if you want to build a feature, change something, like it's very clear where to put what. And that removes a lot of discussion. And I think any discussion that we can just get rid of is often a big help the larger your team gets. And this is something I learned from a friend who switched to JavaScript. He said, like, yeah, in JavaScript, we just, or TypeScript, I think you just write your code, you don't care about formatting, and then you do like the formatter takes care of that for you. And like the whole discussion is gone of how to format your code, like with spaces and whatever. And I think a good architecture, this is one of the things it does. It takes away the discussion, and I think this makes a lot of sense. And what I find a little bit problematic often is that a lot of these architectures are abstractions on top of SwiftUI, if you will. And in my experience, I feel like I often talk to people who chose one of those architectures without really understanding how SwiftUI works, which to me feels a little bit like I get why you want to have like one architecture, but it also feels a little bit backward, because I think the better you understand SwiftUI, the better informed your decision about what a good architecture will be. But it's, yeah. I also agree with your initial comment, Florian, that we are not the right people to ask about this. Like we thought about this a lot, and we talk about this a lot actually, but for us it's mostly theory, because we write very small apps, and like we do not have any of or hardly any of the problems that larger teams or companies have. Like if I need to explain my code, I need to explain it to Florian. And if Florian wrote something, then I'm the only other person that needs to understand it. And so for us, it's so much of a non-issue to come up with like an architecture. And the thing I would try if I was in a larger team, I personally would try to stick with very vanilla SwiftUI. So instead of reducers, I would just use bindings. And but like we are also not the people that write a lot of tests. I think maybe my opinion would change if this would be more of a requirement. I think testing has a few different aspects to it. Like one of them is, of course, knowing that your code is correct, but the other part is also sort of documenting for other people how this should work, and like if people change anything, that your test scrape so that they know sort of, hey, this is how it should work, or what other parts expect. And maybe there, like something like TCA, for example, will help a lot. And yeah, I don't know, like it's very hard to answer. And I think there will be a lot of people who will give you like the one right answer for architecture and solve all of your problems, whether that's TCA or Viper or MVVM or vanilla SwiftUI or whatever it is. I think it ultimately, like you can make them all work. I think it really depends on what you and your team like. If you have people that like functional programming, then TCA might be right. If you're more like probably Viper or something like that. And yeah, I think in the end you can make anything work. That's what we learned. So I think, I don't know how many people know this, or if it's obvious, but we wrote a book called App Architecture a few years back together with Matt. And there, the thing I learned personally from that is that, so what just to step one more step back, is we wrote the same app in a number of different architectures, and they all worked. And so you have to sort of, for each architecture, understand the pros and cons and the weak points and the places where you have to watch out. But then you can make it work really well in any architecture. So for example, in normal MVC, the way we wrote it in UIKit, you have to be careful about observing your model. Like this is something that you can easily make mistakes, and then your view gets out of sync with the model. But once you know that, you can work with it and you can make it work fine. And so, yeah, long story short, you can make any of these architectures work for you, I think.
Yes, and I think it's also, I don't know if this comment refers to what we are talking currently, but yeah, David said, I wonder if personality type plays a role, and I think yes, definitely. So that's very much a personal preference. How much do you like to tie down structure? You know, like how much do you want? How much do you want to leave open to have flexibility, or how much rules do you want? That's definitely different from person to person, and different from team leadership to other teams, right? So that's also, yeah. As Chris said, I think you can make almost anything work if it kind of fits what you do, and you have the right policies around that, the right people around that. Yeah, but as always, architecture is kind of, in the abstract, is kind of this topic you can just talk about for a long time with very little substance. So, yeah.
You can talk about it with substance as well. At least that's what we tried in the book, right? Yeah.
But you see, as soon as we talk about architecture here, we get a lot of comments, at least in the chat. So it's always a topic that. Yeah. Okay.
Maybe also just a quick announcement in between is that we will have a live stream next week, and then we'll be on a summer break. I'm not exactly, we have to check our schedules for how long and where and what. But next week will be the last Q&A, at least for the very near term future.
Yeah. Yes. Okay. And then, but next week we will have the animation chapter for release.
Yes.
And with some iOS 17 editions as well. And I would suggest you go check out today's public Swift Talk episode where we start implementing the observable stuff. I think that's interesting to look into that a bit, because in the end, it's not that complicated.
Yeah, I think it's kind of beautiful, even though it's very limited. I like how they implemented it. Are there any more questions from the chat? We'll have to wait a little bit, because I think the moment we ask, it'll take 30 seconds probably before it gets.
So Franklin says, so the chapter releases will go on hold. So basically, we don't hope so. we will have animations next week, and then we'll also have an advanced layout chapter the week after, and we will get that ready in time, I think. And that's basically the main. Then we are already through the main part of the book now, and then basically we'll start working on some more iOS 17 things and see how we can integrate the iOS 17 content back into the main chapters. So we'll start updating the some of the content that's already out. But yeah, I think in general, the main parts of the book will be out by 2 weeks from now.
Yeah, it's basically two more chapters, and then we're through. Let's see. I also think I don't know exactly where we stand with the advanced layout chapter, the final chapter, how far along that is, but the animations chapter is done. It's from all the chapters that we had to revisit because of iOS 17, the animations chapter definitely has the most stuff we needed to add. So there's the phase animator, there's keyframe animators, there's
custom animations,
there's
completion handlers,
the new animation body API, keys and transactions,
new transition
transitions.
APIs.
So there's a lot, but I think it's just for us, like I think we covered almost everything, and then let's see.
Okay, nice. Then I would say let's call it a day and come back next week once more for the animations chapter. So thanks to everybody who was here live. Yeah, have a good weekend. See you around. Bye-bye.
Thanks.